viewers, you are once again welcome back to the Grammar School Junior online class. I am Akisonya A.O. I will be taking you mathematics. From the last class, you dealt with questions that has to do with Pythagorean triple. So before we start today's work, I want us to quickly have the correction to the last assignment given. So the first question reads correction. The first question reads, find out which of the following are Pythagorean triple. Triples. And so we have 20, 21, 29. Also we have 15, 22, 27. Now from the class, I believe you've been told that the Pythagorean rule is only applicable on right angle triangle. And then the longest side of the right angle triangle is the hypotenuse. So when we have that at the back of our mind, that the hypotenuse side is always the longest side of the right angle triangle. So from this that we have here now, when we have 20, 21, 29, that means automatically that 29 is supposed to represent our hypotenuse side. And so having the hypotenuse to be 29, while the two other adjacent sides, now we have as 20, 21. So with the Pythagorean rule that we have it that the formula as x squared equals to y squared plus z squared. So we have that with the hypotenuse side standing out as the subject of that formula, that means automatically that writing out this question, we have 29 squared equals to 21 squared plus 20 squared. So our 29 squared, which means 29 times 29, supposed to give us 841 equals to our 21 squared, 21 times 21, that gives us 441, then plus our 20 squared, that is 400. So 441 plus 400, that gives us 841. So you can see that what we have there is actually equal to what we have there. So as they are equal, that makes them to be Pythagorean triple. So we can then say thus the set we have 20, 21, and 29 is a Pythagorean triple. Triple. Let's prove the second one too. Let's prove the second one. Let's see if that is going to be equal to each other also. So what we are saying in essence is that for you to check if something is a Pythagorean triple, you want to know if the sum of the two adjacent sides is going to be equal to the sum of the square, and it's going to be equal to the square of the hypotenuse. So the moment they are both equal, that means they are Pythagorean triple. But when they are not Pythagorean triple. So let's check the second question we have. We have 15, 22, then 27. So from our former workings, we can all agree that the hypotenuse in this case now is going to be 27. So we have hypotenuse, which from our formula, okay, let me write the formula first so that we just represent it out. So the formula still remains x squared equals to y squared plus z squared. And so, with that, that means automatically we can say that our x in this case now is going to be 27, while our y can be any of the other two sides, 15, and then our z, 22. So, with that written out, substituting into the formula, we have 27 squared equals to 15 squared plus 22 squared. And so our 27 squared will give us 729. So 27 squared gives us 729, which is equal to our 15 squared is 225 plus our 22 squared. That is 484. So adding up 729. Now if we add up these two together, it gives us 709. So we can see that this statement now is a false, because 729 is not equal to 709. It's a false. And so this is not equal. So this is supposed to be what we have. So that means 729, that means the addition of the square of the two adjacent sides are not equal to the square of the hypotenuse side. And so we conclude that this set of 15, 22, and 27 is not a Pythagorean triple. So that's that on Pythagorean triple. Then we have one other question given. That is the second part of the question. You have to find the length. Find the length. Find the length of the longest straight line, which can be drawn on a rectangular chalkboard. Which measures 2.2 meter by 1.2 meter. Now this is another question. In this question now is the word problem aspect of that topic. Now you are asked to find the length of the longest straight line. The longest, mind you, take that into cognizance. The longest straight line. So, okay, let's go on. Which can be drawn on a rectangular chalkboard. We've already been given the shape of the chalkboard, the rectangular chalkboard. So let's have that drawing. Let's assume this is the chalkboard in question. We now said, find the longest straight line which can be drawn on this rectangular chalkboard, which measures this. Now the longest line that could be drawn is going to be the diagonal of this rectangular board. So we can have it like this. So bringing out that side, we have something like this. And so in this case, you know that every angle in a rectangular box is 90 degrees. So now we have a right angle triangle. We have the right angle triangle being carved out of this. And then the longest side is the diagonal, which now represents our hypotenuse, the hypotenuse side. This is the longest side in question now. So the other two sides are represented by 2.2 by 1.2. So that means automatically we are asked to find this longest side, which we can represent with x. Still on correction. Sorry for rubbing off that. So let's bring down our okay, I'll leave the diagram. So we want to find the longest side, the hypotenuse side. So in this case now we are given two sides. We want to find the third side. Automatically we know that we apply the Pythagorean rule, which still remains as x squared equals to y squared plus z squared. Or better still, let me use another alphabet for the rule in this case because I've used x there. So let me say a squared equals to b squared plus c squared. It's still the same thing. The hypotenuse side remains the subject of this formula. And so, from the question, that means our A will be said to be the x because it's the hypotenuse side, the side we are now looking for. Then the B equals to 1.2 meter, and then the C 2.2. So, substituting all this into the formula, we have x squared equals to 1.2 squared plus 2.2 squared, everything in meter. And so our x squared will now be our 1.2 squared. Our 1.2 squared will give us 1.44 plus our 2.2 squared gives us 4.84 meter. So x squared now equals to 6.28 meter. We are looking for x and not x squared. That means automatically we have to look for the square root. We have to look for the square root of x squared, and not just x squared, but the two sides. So we introduce square roots to both sides. So we introduce square root to both sides. And so we have x squared equals to the square root of 6.28 meter. And so our x equals to 2.5 meter to one decimal place. 2.5. So that means, conclusion of that now is that means automatically that the longest side, let me put that there. So we can authoritatively conclude now that the longest side of that chalkboard, the longest side, say thus, the longest side of the chalkboard is equal to 2.5 meter. So that is that on the last topic that was taught. Let's move to what we have for today. For today, we are going into equation with fraction. Equation with fraction. But before I go further, always remember that in case you have any question, any feedback whatsoever, can always get through to us with that address up there, agssnr@gmail.com. So equation with fraction now. Equations with fraction. Yes, I'm going to start this. From the very beginning. I'll start with what do we mean by equation. When we talk about equation in math is talking about a mathematical expression that has an equality sign in between them. That is, we have one mathematical expression on one side being joined to the other one with an equality sign. That is telling you in essence that you may have, no matter what the length of the expression is, in as much as there is no equality sign in between the expression, it is not an equation, but rather just a mathematical expression. This is what I'm talking about. You can have 2x minus 3y plus 4x plus 3 minus 2z. You can see that this expression I wrote here now is very long, but as it is, it's still not an equation. And also we can have 2x equals to 0. As simple and short this one looks like, this is an equation. Reason being that you have an equality sign joining what is on this side to this side, and so this is an equation. Quickly, we all know what we mean by fraction. We have a number such that we have numerator over denominator. That's what we refer to as fraction. So fraction in math comprises of numerator over denominator. Now, when I said how we now handle problem that has to do with equation with fraction. When you have an equation whereby there are fractions in such question, how do we handle that? And that is our objective. How to handle problems that deals with not just equation now, but equation that now has fraction. We have problems that might be as in the denominator, the one down now. Problems that deals with monomial denominators, and then the one that has binomial denominators. So I'll start with the monomial denominators. So I'll take some examples now. Example 1. Let's suppose you want to solve this. That you solve for the unknown. Solve for the unknown in a over 3 equals to 3. Now this is the question given. You want to solve this. You can see that you have a fraction on this side. There are two ways into solving this problem. We have the cross multiplication method, we have the LCM method. For cross multiplication, you can only use cross multiplication as in it is easier for you to use cross multiplication when you have singular fractions. What do I mean by singular fractions? I'm coming back to this. Supposing what we have is a over 3 equals to 2 over 4. This, or like what we have 2. What we have here, 3. We can put this 3 over 1. Then it is easy for us to use cross multiplication in this case. Every problem in math has a kind of easy access method, even though all the methods that we could use could be applied to any of the questions. But there are some that are straight pathway to the question. They won't give you problem. So if you have to use cross multiplication at all, make sure that the question that you have at hand has singular fractions. So for this one, I can use cross multiplication, like I said. So already I've changed the 3 over 1. 3 over 1 still remains 3, just for it to look like the other side. So cross multiplying. Cross multiplying, we have a over 3, which equals to 3 over 1. Cross multiply, and so we have a times 1 equals to 3 times 3. So a times 1 gives a equals to 3 times 3, 9. So our a equals to 9. And that's, you can see that automatically is so easy using that too. Also, we can use the LCM method for any of the questions. I'll take another question and I'll use LCM. Example 2. Also solve for the unknown in let's say you are given x equals to, let me say find x. Let me just say find x in x equals to 12 plus 3x over 5. Now look at this. Like I said, if you look at it very well, also we can say that this also deals with singular fraction. If you put this one over 1, this x over 1 to look like this, you have a singular fraction here, a singular fraction here. So you can still go ahead to use cross multiplication. But in this case, I'm going to use LCM method. So using the LCM method, I'm going to put x over 1 equals to 12 plus 3x over 5. Now, using the LCM method, in this case now I want to use the LCM method. Let me put it there. LCM. I'm using the LCM method. The LCM method. Now, we will look for the LCM of the denominators. So the LCM of the denominators in this case now, the denominators are 1 and 5. So the LCM is going to be 5. We now multiply through. What we are trying to arrive at is we are looking for a means of removing it first from being fraction. We want to take it away from being fraction. And so we multiply through with the LCM, each of the terms in that question. So we have x over 1 times, okay, let me write, multiply through. You multiply through with the LCM. Let me write that. Multiply through with the LCM. And so we have x over 1 times 5 equals to 12 plus 3x over 5 times 5. So this one in 5 still remains 5. So that means x times 5, that is 5x equals to 5 cancel 5 there. We are left with 12 plus 3x. So you see that by the time we multiply through with the LCM, we've been able to achieve what we are after, removing it from fraction. So we now have just a linear equation, not fraction anymore. And so the next thing we collect like terms. And so we have 5x, bringing this to this side, we have 5x minus, when plus comes to this side, when it goes over the equality sign to the other side, we have minus 3x equals to 12. So 5x minus 3x, we are left with 2x equals to 12. It is x we are looking for, that means we divide both sides by 2. So divide both sides by 2. And so we have 2x over 2 equals to 12 over 2. Then our x equals to 6. So with that, I want to believe that we are okay with this. We can't go into the binomial denominator today. We will take that from next class. But rounding up today's lesson, you can see that when you want to handle problem that has to do with fraction, equations with fraction, you can actually use two methods. You have the cross multiplication method, you have the LCM method. But don't forget, like I said, there is always a straight path method to each of the questions. So when you have singular fractions, all what we did today, we still have singular fractions. When you have singular fractions, such as in you don't have multiple fractions, whereby you can have two fractions on one side, 2 or 3 more on the other side. In that case, the best method is the LCM method. The best method for you, the straight path method to it that will not give you any problem, is the LCM method. So I'm going to give you some questions to handle by yourself, and I'll be expecting your feedback. So I want you to try this by yourself at home. So solve for the unknown. Solve for the unknown. And 5n over 3 equals to 3n plus 7 over 2. Also, x plus 9 over 5 plus x plus 2 over 2 equals to 0. Now 1 over x equals to 2 over 3x. So I'm going to take it up from here next class. I want you to try to solve this, and I'll take it up from there. We'll do the correction to this. So before I will close for today, once again, don't forget, for your feedback, you can access us through Abeokuta Grammar School Senior Online Class at gmail.com. And I still remain your teacher, Akisoya A.O. Good day.